record. And I would like to introduce Jamie Robinson. Jamie is the technical lead at Safe System Solutions, and before that worked with me at VicRoads, and where he was in a variety of roles, including the technical lead of traffic engineering and design. And Jamie does spend his life in very technical challenges associated with road design, road projects, and auditing a lot of the detailed end stuff. And so hence I have asked Jamie to present this part of this module, which is associated with the road safety auditing of the design phases. Now, I have been talking about that a bit in sort of general process sense. Jamie will give you some of the specifics of things to look for, show you some examples, and it'll give you a good feel for when a design set is, provided to you, how to go about looking at things, and how to consider all those risks and report it up. So do feel free to pop in your technical questions to Jamie, and I'll be monitoring the chat behind the scenes. Jamie, I think you got some slides there, and I think I enabled it so you could share screen. So I'll let you have a go at that as we go. Jamie's currently doing a number of Austroads projects and helping out with design guidance. There's one interesting one in particular on road safety barriers in narrow medians, it's treatment of narrow medians or medians, not specifically barriers, but I think a lot of the focus landed on barriers, and a few other projects. Jamie's the lead presenter in our 3 or 2 day road safety barrier design technical training course, which is done in person, if any of you have come to that or interested in it. But over to you, Jamie, and I'll be behind the scenes and may jump in.
Thanks, Ken. Good morning, everyone. I'd like to start just by setting the scene a little bit and discussing the difference between a standards review or a design review, as it may be called, and a road safety audit. Often as technical people are asked to do sort of one of the above, and the lines do get a bit blurred. But I want to stress that a standards review really does focus on compliance with standards. Compliance with standards generally does lead to safer outcomes, but doesn't necessarily mean that all safety issues are eliminated. It's important to remember that standards often are expressed in terms of desirable values, minimum values. We talk about design exceptions and extended design domain. And it's when we're dipping into that sort of territory that we can see safety issues arise. Any road project brings together all sorts of different design elements, and it's a particularly dangerous situation, or potentially dangerous, when we're combining various minimums. So a road safety auditor really needs to look beyond standards. It's possible that something is in accordance with standards and is not safe. And similarly, it's possible that something doesn't meet standards but might be safe. As a road safety auditor, you really need to put yourselves in the position of the various road users that might use a piece of road, and think about, would you feel safe? And by all means, if there's a relevant standard that is not being complied with and that supports your view, you ought to quote it, but standards should not be your starting point. When you are undertaking a road safety audit, and particularly one at the detailed design end of the spectrum, you'll receive lots of information. You'll have a pretty hefty set of, you may have a pretty hefty set of drawings. If it's a larger project, you'll have all sorts of plans, layout plans, details around signs and pavement markings and drainage and signals and all these types of things. In addition to that, there may be some other information that you are provided or that you might like to have. The information that will help you understand the context of the project and how the design has been developed. Some of that information includes details of the design vehicle. Some of you, I'm sure, have heard that term. The design vehicle is the largest vehicle that's expected to use a piece of road on a regular basis. And that really does influence a lot of the geometric elements of a project. So just stepping back, I think the title of this presentation includes the term heavy vehicles. Why the focus on heavy vehicles? It's because it's those larger vehicles using a road that do impact to a fair degree the geometric layout of our roads. And the second reason is that heavy vehicles really are highly overrepresented in the crash problem on our roads. So it's critical that we consider them in the audit process. So we might have details of the design vehicle. It might be something small, a service vehicle like a garbage truck in a more local environment, or it might be a large truck like a B-double or even bigger at a major intersection. Understand the speeds that you're dealing with. Again, the speeds that we're designing to will influence lots of things, a geometric layout, site distance requirements, and so on. Swept paths. You may be provided with swept path diagrams to demonstrate that the vehicles that need to can negotiate a piece of road, and particularly the intersections that you're looking at. If you're not provided with that, by all means, ask for it. And if that's not readily available, that's a bit of a red flag. Swept path checks should be done as an integral part of the design process. Traffic data, volume, types of vehicles, vehicle classes, particularly numbers and proportion of heavy vehicles, details around pedestrian and cyclist use can be important information to have. The crash history of a site, and we've got a little bit of a disclaimer there. Some auditors don't like to know the crash history of a site. They prefer to go in with an open mind and not be influenced by what's happened in the past. Crashes on our roads often do occur in a random fashion. So if that's the case with our crash history, we don't want to be influenced by that too much. But certainly if there is a trend of a particular crash, you want to know that your design is going to address that obvious problem. If audits have been undertaken previously, and if it's a large project and we've been charged with doing a detailed design stage audit, it's likely that an audit has been undertaken at an earlier stage as well. So it can be useful and educational to see that report, check off which of the issues in that report have been addressed, whether any remain, whether you agree with those issues in the first place. On top of those things, I encourage all auditors to seek any information from the project manager or designer that they feel they need to have to understand the design intent. I'd like to step through now a few common issues that we come across a lot when undertaking audits, and I expect you will too. The first is around design vehicles and swept path requirements. It's sometimes the case that a design doesn't cater to the swept paths of the chosen design vehicle. I mentioned that the design vehicle is the largest vehicle that we expect to use a piece of road on a regular basis. We also use the term checking vehicle or check vehicle. That's a larger vehicle again that we need to ensure that our design will cater to. But the check vehicle is one that comes along only once in a while. It may be under an escort or traffic management. And because it comes along so infrequently, we accept that it might do some unusual, undesirable things. A design vehicle needs to be able to negotiate the road in a desirable way, make turns from the correct lane and not encroach opposing traffic lanes, not cross curbs and so on, whereas a check vehicle might be allowed to do some of those things. We need to ensure that the choice of our design vehicle and our check vehicle is correct, and every project will have one or more design vehicles and checked vehicles, it's sometimes the case that the design vehicle differs between movements. Perhaps you're looking at an intersection. Certain vehicles make certain movements, but not others. So you might have different design vehicles for different movements, and similarly checked vehicles. To make your decision on design vehicle and checked vehicle, you can refer to traffic classification counts, but more importantly, you can get out on site, observe the vehicles getting around, think about the surrounding land use, think about potential changes to surrounding land use that might influence the types of vehicles that are present or going to be present. We're talking about design stage audits, but on the most part, design projects are upgrades to existing roads, and you can put yourself out there on the spot and see what's happening. That's a critical part of the process. Potential issues associated with getting the choice of design vehicle wrong include vehicles encroaching into areas they shouldn't. It might be into adjacent traffic lanes when making turns. A vehicle needs to swing out wide to make a turn, for instance. They might encroach pedestrian areas. That might be cutting the corner, and the inside of the turn movement, mounting a curb at the corner of an intersection in a pedestrian area. You might see conflicts between vehicles within intersections. And a telltale sign of a lack of space is impacts with roadside furniture, knockdown signs and the like. Now, these are all issues with there not being enough space for vehicle swept paths. We can go too far the other way as well. If we're providing too much space, so if we're adopting a design vehicle that is too large, we can end up with excessive areas of pavement, which can be difficult to delineate. It can mean that smaller vehicles can make turns at excessive speeds and so on. And so it's important that our intersections are as compact as possible, subject to satisfying the space requirements of our design and check vehicles.
Jamie, a question's come in there. How do you check choice of design vehicle? Many projects auditors may not have all the info. And I suppose also generally, even if you do get all the info, how do you decide what the design vehicle is?
If you're lucky enough to have a design report, it should capture those choices. If you have some swept path diagrams, it should be evident what vehicle has been used. As part of a site inspection, you can have a think about the types of vehicles that are getting about. So there are different ways to investigate what is an appropriate choice of design vehicle. When you're reviewing a design, and it can be difficult without having those swept path diagrams, but you ought to think about whether there is sufficient space to accommodate the movements that are required. And if you don't have the information that you would like, I would suggest that you put it back on the designer to provide it and demonstrate that the piece of road is doing what it needs to do.
Thank you.
There is lots of guidance available on swept path requirements, clearances between vehicles and elements of the road between opposing vehicles and so on. This is where you need to look to the Austroads guides, parts 4 in particular. And there are a couple of snips there. One on the left showing requirements for concurrent right turns at an intersection. Important things to note there are the minimum radii that are indicated. The software that's used to generate swept paths is, I guess, open to a little bit of, misuse, for want of a better term. It's possible to really wind things down to make things look better than they might be. We really need to make sure that swept paths have been generated by the book. And a key part of that is adopting these minimum radii as specified in the guides. There are clearance requirements between opposing vehicles, between vehicles and roadside objects like curbs and signs. Typically, that's 0.5 metre. In the case of these concurrent right turns here with a double right turn, we need a 2 metre clearance. So this is a situation where we should consult the relevant guidelines. On the right-hand side, we've got a swept path diagram for a prime mover and semi-trailer. That's a 19-metre long vehicle, which is a fairly common design vehicle. This diagram is at a particular radius and turn speed. It's a 20-metre radius, which equates to a turn speed of about 15 or 20 kilometres per hour. It's important that we are using the correct radius. This radius and turn speed might be appropriate for a movement that doesn't have to yield. So it might be a free flow left turn or something like that. If we had a movement that potentially would need to yield to an opposing stream, we can adopt a lesser radius and a lower speed. But we certainly shouldn't use a tighter radius than this for a movement where that might not be the case. Here's an example of a swept path diagram, and not a particularly good one at that. At first glance, it may appear that everything's okay. You can see a blue and a purple swept path, right turns from opposing directions. There does appear to be a clearance in the middle here. But if we inspect more closely, we can see that the blue movement is made on a fairly constant radius. That doesn't look too bad. The purple one, on the other hand, does some funny things. If we follow this sort of line along the centre of the vehicle path, we've sort of got a short, sharp turn here. It straightens up and then it turns sharply again. So this really looks to be a situation where an intersection has been designed within a confined space. Some swept paths have been plonked on top, and an attempt has been made to show that these vehicles can get past each other. The desirable thing to do would be to construct these swept paths on a single radius in accordance with guidelines. And if that was the case, I think you'd see quite an overlap within the middle of the intersection of these swept paths. A telltale sign is these little arrowheads. If you look closely, you might pick them up. They basically represent a mouse click or a change in direction along the vehicle path. So we've got quite a few of them along both vehicle paths, in fact, which is not the way things should be done. A better swept path diagram would nominate the radius that is being used and the turn speed for each of these movements, and certainly wouldn't have all those little changes in direction. As an auditor, we would then need to think about what is the consequence of the intersection being designed in this way. It's unlikely that two vehicles approaching from each direction, from opposing directions, would continue into a collision situation. They would probably take evasive action. It's possible this could result in one of those vehicles ending up in an area they shouldn't. But stepping back, I suppose we need to think about what is the choice of design vehicle from each approach, and what is the likelihood of two of those vehicles arriving at the same time. There are ways that we can avoid this situation. We could separate those movements through signal phasing. So there are different things that can be done, and these are things that you might recommend happen as an auditor if you're auditing this situation. So in the middle of this intersection, we have a potential issue there. Another at the top left corner of the intersection might be a lack of space for pedestrians within the road reserve at that corner. At the bottom left, a potential standards review finding would be the fact that the signal conduits are shown to not be within the road reserve. So this certainly is something that you might pick up as part of a design review, but doesn't have any safety implication. And as an auditor, we would not be inclined to comment on that. Another example of a swept path diagram. And this was a design that we inherited, which had some swept paths performed on it, and the suggestion was that it satisfied the required movements. We did our own checks because we weren't so sure about that. And when drawn as per guidelines, and you can see some radii nominated there, the movements have been constructed using a single constant radius curve. You can see that there are quite some issues with this layout. One is that the left turning bus, shown in blue, encroaches on the pedestrian area here significantly. Now, this is the rear axles and wheels of the vehicle that are ending up in this space. I should mention that it's often the case that there are lots of lines on our swept path diagrams, and it can be difficult to understand what's what. It's important to understand the full extents of the vehicle envelope or swept path, and usually that's sort of the front and rear corner of the vehicle. Other lines shown here are the dashed lines represent the wheel paths. There's also often a line along the centre of the vehicle. And then at the outside of the swept path, you can see two parallel lines on each side. The outermost of those is a clearance line, which represents the 1/2 metre clearance, desirable clearance that we are to provide to roadside objects such as curbs and so on. So it's fairly typical for that offset line to be shown as well. So important just to know what you're looking at when you're reviewing these diagrams. If we look at some other movements at the same intersection, when drawn in accordance with guidelines, we see quite an overlap between some movements that would be allowed to occur concurrently. When you're out on site, you might observe some signs such as tracking behind curb, which can point to an issue of a lack of space for the design vehicle. But that's not always the case. Often there might be an issue with speed compliance or a lack of delineation that results in vehicles traversing these areas that we don't want them to. Associated safety issues might be around excessive speeds. There's also a possibility for loss of control or instability with vehicles crossing curbs. Perhaps the curb might break up and present a hazard as well. Here we have a concrete pavement and a raised island, also in concrete. And you can see some tyre marks on the island, encroaching a pedestrian area here, which is certainly not a desirable situation. I'd suggest here the lack of contrast between the road pavement and the island is a contributing factor to that. This is in the Port of Melbourne. It's also been suggested to me that excessive speed is part of the problem here. So there's a risk to pedestrians when vehicles encroach pedestrian areas such as they are here. I'd suggest that someone standing here is perhaps not so much at risk as someone on the other side of the road. Now, the direction of travel at this location is towards us. So someone standing on the island here at the tactiles would be in view of an approaching motorist. and you would hope that they wouldn't continue on that path if someone was waiting there. On the other side of the road, however, the pedestrian might be a little more out of sight, but this is the area where the rear axles of a turning truck will end up if it takes an inappropriate line. And this is a common pedestrian safety issue, that a pedestrian waiting at an intersection corner is struck by the rear end of a turning vehicle, where the rear axles encroach. The rear axles take a shorter turn on a smaller radius, take a shorter path than the front of the vehicle, and there is potential for the pedestrian to be struck. It's common to see signs knocked down on our roadsides, and this can point you to a lack of space. Another common example is the keep left sign on a splitter island. We often see them knocked flat. It's a common situation to use a sort of a rebounding post. In those situations, it can point to a lack of space for a turning vehicle. Another common safety issue relates to sight lines. The intention of sightline requirements is to provide enough time and space between different vehicle users to allow them to take appropriate action. So we have sight distance requirements for drivers of vehicles, for pedestrians. Sight distance requirements may be measured from a driver eye height to the pavement, to an object on the road, to a part of a vehicle, such as a tail light or the top of an approaching vehicle. There's a whole suite of different sight distance requirements that I guess it's important to have some familiarity with and to know where to look if you're reviewing those. It's sometimes the case that our sight distance requirements are restricted, and that can occur due to the road geometry. Horizontal curves with objects on the inside of the curve can limit sight distance. Vertical curves, crests particularly, can limit sight distance. Near intersections, it's often the case that parked vehicles, utility poles and other pieces of roadside furniture can impede intersection sight lines. Another dangerous situation is where we have a shallow approach angle or stand-up angle at an intersection. You may have heard of Y intersections, where you have acute intersecting angles of roads. That makes it difficult for approaching motorists to view each other, and there's a tendency for failure to give way crashes at those situations. One of the sight distance requirements discussed in Austroads is SISD. Maybe we can offer a prize, Ken, to the first person that can tell us what SISD stands for. Right. Or do we have a poll question on this one?
Oh, we might have, but they're into it already. So, it looks like Emily with safe intersection sight distance was first. You happy with that, Jamie?
Safe intersection sight distance it is.
Emily's on the board with a prize. Kez has got that noted, no doubt. Lots of others in there quickly as well with the same one, but just not as quick.
So this snip comes from Austroads Guide to Road Design Part 4A. And there are a few important things that it demonstrates. We need to consider sight distance requirements in the horizontal and the vertical plane. So vertical geometry of a road, and particularly crests, is important to achieving sight distance requirements. It's also often the case that an intersecting road or driveway, its vertical alignment might see it sort of approach the main road on an upgrade, which can lessen sight distance, the available sight distance. Safe intersection sight distance is an important consideration at intersections. It provides enough time and space for a vehicle on the main road, such as this one here, to see a vehicle enter a collision situation from a side road or a driveway. It gives enough time for this driver to see that situation unfold, put on the brakes and come to a stop before reaching the dot here. In the worst case, a vehicle might stall in this at this location here. So that's certainly a requirement that we should provide at any driveway or intersection.
Jamie, there's just a bit of some technical questions in there around the turn radius. So is 15-metre turn radius the minimum that needs to be tested for heavy vehicles? Swept path in the earlier one shown was 12.5, and then Cheston's saying that thinks that's a bus, which is shorter. Do you have any answers on that?
Yeah, so there are different radii for different vehicles. 12.5 and 15 metres are pretty common radii that we do use. Shorter vehicles can turn on some smaller radii. So it's important there to look to, there's an Austroads document, the Austroads Guide to Design Vehicles and Swept Paths. It's not part of the Austroads Guide to Road Design Suite. It's a separate Austroads document, and it spells out the accepted or the radius, the radii that you should adopt for different design vehicles. So there's no one magic radius, but 12.5 and 15 are fairly common.
Thank you.
Another thing that I'll point out here is that it's important whenever we are looking to the Austroads guides that we also consult the jurisdictional supplement to the guide if there is one. One little sort of thing that stands out to me here is that the Austroads Guide nominates a setback distance that we had to measure our site distance from. The Victorian supplement for one says something a little bit different to this. So always consult your jurisdictional supplement, which does take precedence over the Austroads guidance. Here's a little real life example in Melbourne where we had a fairly wide urban road with very limited pavement marking, where the width allowed the road in congested conditions to operate as a 4-lane road, which had its safety issues. The decision was made to formalise parking lanes along each side, and you can see some yellow lines there to indicate that, and to deter that behaviour of making this a 4-lane road. Those parking lanes were extended to 10 metres prior to each intersection along the route, as per standards. And that's what it looks like post-implementation. Cars parked very near to intersections, and this created a dangerous situation, which is fairly typical sort of black spot project scenario, with vehicles entering from side roads being struck by through traffic. You can see that a fraction of a second later, this car is upon you. There's very little sight distance available, especially when there are vehicles parked. And you can imagine if this was a hire vehicle, a small truck or a van or something like that, that the situation would be worse again. So whilst this project addressed one issue, it created another. Perhaps I'll put it out to you guys to suggest some things that could be done now to address the risk that's been introduced.
Yeah, all right. Pop any ideas you've got in there. It's looks like a few people are saying it's a common issue that they're facing in their local governments or their municipalities or the like. So I'll give it a second for people to pop in their ideas and see a few of them coming in now. So we've got bringing the hold line forward, removing or eliminating parking, reducing the length of the parking. What else have we got? Just looking for anything that's different to that. Threshold treatment to slow cars. Extend the curb, so a curb outstand, curb extension, curb build out.
I'm liking all of those.
You want prizes for everybody?
Yeah, everyone a prize.
Okay, he's done it. He's gone with everybody. Kez, it's a big prize. It's like they've hit the pinata. It's all fallen prizes. Good. Okay. I'll leave that with you, Kez, to work out. Back to you, Jamie.
So obviously here we've got a situation where sight lines have been compromised. We want to improve those now. We can do that in a number of ways. Sort of an easy, one option would be to ban parking near to the intersection. Now that's often easier said than done. Even if you do put in some signs to do that, that won't necessarily stop people parking in these areas. A better outcome would be to bring the hold line forward. As part of that, you might construct a curb out stand here to shelter the hold line that has been brought forward and vehicles waiting at that hold line. So that'd probably be the best situation. Construct an outstand here. That might result in parking, losing a parking bay or two, bring the hold line forward to the edge of the through lane and really open up sight lines. If you had deep pockets, you might look to reduce speeds on the main road through some vertical deflection devices, even a raised intersection. Probably lots of things that you can do there, but probably the most common and usually the most practical is to bring the hold line forward or to at least improve sight lines from the existing hold line location. As I mentioned before, there's a whole list of different sight distance requirements. The differences between some of them are subtle. Stopping sight distance and approach sight distance are two of the sort of most common and basic. They're actually numerically equal to each other. The difference between the two is that is the height to which they are measured. So they're both measured from driver eye height. Approach sight distance is measured to the pavement level. So that's particularly important on approaches to intersections where you've got hold lines, turn arrows, and these types of things. Stopping sight distance is a requirement that should be applied continually along roads at all locations. It's measured to an object on the road with an assumed height of 200 millimeters. So that might be a rock, or perhaps in the worst case, a person that is lying on the road. And we need to provide enough time and space for a driver to see that situation and take appropriate action. So they're mandatory requirements. Others are more in the nice to have category, such as entering sight distance, which is intended to allow someone turning onto a major road to do so and get up to speed without impeding traffic on the main road. All sorts of sight distance. Others not listed there include crossing sight distance, which relates to pedestrian crossings. So you can look to guidance and crunch the numbers. You can put yourself out on site as an auditor, undertake crossing movements and think about whether you would feel safe. Do you feel like you've got enough time and sight distance available to you to make the required movements?
So Jamie, just before you jump onto the rural remote ones, it's a question on the curb outstand idea back at the previous slide. What if there's a bicycle lane? How do we How do we manage that? Any thoughts
Yeah.
on that?
That's a great question. If we do introduce a curb outstand, we need to make sure that we're not squeezing up cyclists if they're present. If there's a bike lane, we need to maintain a width for cyclists past that outstand. It is sometimes the case that we construct an outstand, like so, and the result is that cyclists are sort of funneled into the traffic lane, and we create a potential conflict there. So, an important consideration. I just wanted to touch briefly on rural and remote roads, which present a unique set of challenges. They're often roads like this one, they may be unsealed. They're roads that don't carry high volumes. They're roads that are unlikely to have a lot of money thrown at them, but they really do, relative to the volumes that they carry a higher risk to road users. Particular issues on these roads occur at locations where the road environment changes, where the geometry changes, or there might be roadside hazards present, or variability in the surface, things like that. They're often long, monotonous pieces of road. Issues occur at locations where things change. So it's important to do things like provide good delineation at curves or at other features such as dips, or where there is some pavement issues or something like that. Provide advance warning to motorists at these locations is critical. Here is a list of common issues that occur at intersections. Now, a lot of these are alluded to in the checklists that are in the Austroads Guide to Road Safety, the road safety audit part. So I encourage auditors, and particularly new auditors, to use those checklists when they're doing audits. Many of the items in those checklists won't apply to a particular project, but if you're going through it, you're certainly making sure that you're doing a thorough job. So, look, I won't go through these sort of one by one. If there are questions or any items there of particular interest, I'm happy to discuss them. This list relates to intersections. So at intersections, we're dealing with potential for conflict between opposing or crossing vehicle streams. We need to provide enough space and appropriate crossing treatments for vulnerable road users. These type of things. At mid-block locations, the focus is a little different. We're more concerned with the roadside environment, with the road cross-section, ensuring that there's appropriate space and separation for vulnerable road users, these type of things. So on the next slide, we list a number of issues that particularly apply to mid-block locations. Any questions there at all, Ken?
Yeah, there was just a question on what is a Danish offset, and I was just about to show that to make it easier than trying to explain it. I'm going to steal the screen off you, Jamie. Sorry, bear with me. Just going to our website because we did a snippet. It was our first ever snippet, actually, Safe System snippet. We're up to around 200 and something now. A Danish offset is sometimes called a Z crossing, and that's the one where you walk into the road and along the median and back again. And actually, I think somebody did their assignment on that potentially. So this one was just showing that it's not as good to do it this way because the vehicle isn't facing the traffic. So feel free to jump on our website and go up here to news and snippets, and you get lots of these little snippets there of lots of, okay, 197 of those. So that was that one. Back to you, Jamie. You can steal screen from me again. I hope people saw my screen there.
Yes.
Sorry, I probably caused trouble by doing that. We're going to take a break shortly for people to have a coffee. So dynamic visual obstruction, was that in there at the intersection one? Yep, dynamic visual obstruction. We talked about that in module 1 quite a bit with using the example of the left turning vehicle in a left turn lane blocking the sight lines to a vehicle that's behind it. It's sometimes called masking as well. That's the sort of idea of dynamic visual obstruction. So I suggest you jump back into module 1 if you want to see a bit of that in more detail. Pop in any other ones that you want some details on. Some of you have done assignments on some of these as well. The person doing the Danish offset assignment is from Denmark. There you go. It's like we planned that. Okay, Jamie, any other things to cover? I've got a couple of questions for you, unless you've got more slides.
That's the last slide, Ken. So happy to take any questions.
Well, I'll see if anybody else has any questions, but just in our last couple of minutes with you, I suppose what's your advice to any of these people who maybe don't have that level of technical knowledge that you do and the ability to, take a 500-page design plan set with long sections, cross sections, and drainage plans and geometric layouts and be able to sort of interpret that? Are they just to not do these audits, or what's your advice there?
No, well, any audit requires a team of auditors, 2 or more auditors. So if you don't have the technical experience, you certainly can still add value to the audit process, but at the detailed design end of the process, it does become more important to have someone involved in the audit team that does have that sort of technical knowledge and familiarity with guidelines and interpreting design drawings. So yeah, it's more at the sort of existing conditions stage audits and concept design stage audits. There's less importance on that sort of having that technical knowledge in the audit team, but yeah, the detailed design stage where you're focusing in on those detailed issues, it does become more important.
Yep, good, thank you. Daniel's asking for the source of the figures on slide 10, which I think is the one with your clearance, 2 meter clearance between opposing turns and the general turn radii overheads that we used to plonk on top of actual physical designs, which I don't know if we even have those anymore. They're from Ostro's Guide to Road Design Part
4A, if you're referring to this one, the one on the left will be from Part 4A, I'm fairly confident.
Yeah.
The one on the right is from the Ostro's Design Vehicles and Turning Paths Guide.
Yes. So that's the guide you were mentioning before, which assists in the vehicle and the turn radius. And as I say, we did used to use those you print them out on an overhead transparency that some people won't even know what I'm talking about there, and then you lay that on top of the physical plan design that was in, and you'd move it around. Give us a thumbs up if you ever did that. We'll see. Gauge the age of our audience. Oh, okay, we got a few. Yep, there's a few there. I'm sure. Yeah, I know. I am showing my age, and I've just got glasses as well, so that's really all coming together. I'm sure the younger generation just do it all in CAD, and it's quicker and easier and more accurate. But anyway, okay. Well, good, Jamie. Thank you for that. I don't think there's any other particular questions that have come in at the moment, so we might take our 5-minute break now. And I see Tony Bull has arrived in the room, so I'm going to promote him to a co-host so he can turn on his camera and share his screen. So let's take 5 minutes, and when you come back, we'll introduce Tony. Yes, I think you might have. And it's back again. Well, welcome back, everybody. Hope you filled up your coffees there. And we're on to our second part of this module, which is around the road safety auditing of construction sites, traffic management plan, traffic guidance schemes, and the whole lot. And we're very excited that we've got Tony Bull to present that. Now, some of you will undoubtedly know Tony because he's been working in the field of construction site safety, road safety, and road maintenance and upgrades for quite a while with the Victorian government for quite a while. He'll show you exactly how long, I think in a slide coming up. But very recently, we're really excited that Tony joined us at Safe System Solutions as a senior project manager and one of our key trainers around the ASHTAS system, which is the Off-Road Safety Hardware Accreditation Scheme, which is around requiring people that work with road safety barriers in any description that they have a license. And we are running the training and licensing scheme for that, or we're one of the providers. So Tony will be out and about around the country, training people up and testing them and giving out those licenses. But we asked Tony to come in on this one just because of that extensive experience around construction site safety, thinking about safety of road users and workers, and doing audits and running training around the world, actually, in construction site safety. So over to you, Tony. And as I say, about 40 minutes, 45 minutes is good.
We're at 11:30. Okay, no worries. Thanks, Ken. Morning, everyone. Ken, before you disappear, what's our audience? Are they, I should have asked that earlier. We all over the world, or Australia, or?
Australia and a few states represented, East Coast mainly.
Very good, no problem at all. All right, so thank you all very much. Move on to the next slide. There we go. So, as Ken said, I had almost 39 years with the Department of Transport / Vic Roads, working mainly in the fields of road construction, road maintenance. But yeah, I've joined Safe System Solutions on the 30th of Jan, and very happy to be on board with Ken and his team. Promoting this safety at roadworks, and it's an area that I've been involved in for many years. I've presented at the road safety audit course. It's probably beyond 20 years now, so it's been an area of passion of mine, ensuring that this is all about the safety of people at the site, people who are going through the site, or people approaching the site. Just ensuring that whatever system we use, whatever signs, devices, and the like, they're used correctly, and the result is that no one is injured due to the works or due to the actions of people driving or walking or riding through those sites. So it's so important that we have this process. There's many processes undertaken to ensure that happens. We have the compulsory training, we have the surveillance, we have the project managers and the like. But the great thing about a road safety audit is this independent set of eyes, and that's a really important part of this whole road safety audit process, is that it is an independent team that come and check out the well, the potential of, what could go wrong. Have all these risks been looked at? Is there any hazards that haven't been managed or mitigated and the like? So it's a really important part of the whole package of making sure a site is safe. Oftentimes as a project manager, you put the blinkers on. All you're focused on is getting the job completed, rather than looking at the big picture. So this is a really important part of the, as I said, managing roadworks on our road network. As Ken mentioned, I've been fortunate enough to be on 3 different international projects: Philippines, Dubai, and Indonesia. I was on the Australian Standards Committee for the 1742 Part 3. Also, Austroads Committee member that put together the guidance material, and it's only through my retirement from Vic Roads or Department of Transport that those memberships have now ceased. But was certainly heavily involved in the guidance material that's been produced by Austroads, and currently looking at the national training requirements for people who are working in this field. As I mentioned, I've been a road safety auditor training for 20 odd years. I've also trained in the worksite safety traffic management for traffic controllers and traffic management implementation. And certainly the road construction, road maintenance, and the asset management are my areas of strength. And Kez or Ken, if anybody's got any questions, please just anytime through the presentation. We don't have to wait till the end, so happy to field any questions as we go through the presentation, Ken or Kez. So happy to take any questions if anybody's got anything.
Yeah, well, we'll be monitoring it in the background, so anybody who wants to pop a question in, please do.
Cheers, thank you. These photos was, and I've got to now say it's become difficult. I worked from the Warrnambool Vic Roads office for over 30 years, and to say my office now, it's not anymore. But if I refer to my past employment, it's just pure habit. But this was a car park at the Vic Roads Warrnambool office, and they had dots just to depict the spacing to park. And when you look at it, it was always in my mind, and most people's mind, it was probably meant to be 90-degree parking, but it could have been seen as 45-degree parking. And this is an outcome of what was perceived to be a way of line marking or defining where to park your car. But the perception that someone saw, they thought it was 45, someone else thought it was 90. Now this is just I suppose a very simplistic view of what people see. But unfortunately, what happens is the people who are putting up the signs, the devices and the like for traffic management at roadworks, as I mentioned, we often have the blinkers on and don't see the bigger picture of what people or what we want the travelling public to follow. Do we want them to go left? Do we want them to go right? Do we want, have we given enough guidance for them to get through the site safely? So, to understand that what signs and devices we're actually putting up to ensure we're getting a safe outcome is so important. And as mentioned, road safety audit, it's not a compliance audit. Yes, we need to make sure that the codes and the Australian standards and the Austroads guides are reference documents. They're the rules that we've got to follow, but they're not going to give you every scenario that is going to be put in front of you as for an outcome. So therefore, that's the guidance. That's the standard. That's the set of signs we've got to use. There's dimensions of signs that are meant to be used on freeways, local roads and the like. So that's the standard. The guides is how they've got to be implemented. But from a road safety point of view, we're looking at beyond that. We're looking beyond the compliance audit. As I mentioned, we're trying to ensure that the site has been signed to accommodate all road users. And so often, and I've got a couple of slides in a minute, pedestrians, they often are forgotten road users. Cyclists are another one that we need to ensure that we're covering off for everyone in the way that we're undertaking or providing traffic management. It's just I can't stress it enough that we need to ensure that we are meeting the needs of all the road users. As I mentioned, the Austroads now have 10 parts to temporary traffic management. They've replaced a lot of the state codes of practice and guidance material. Each state will most likely have their own additions to these because we're one country, but the different states within Australia, we have probably different terminologies. We're trying to introduce this common terminology, but that could take some time to try and work through that. But it's been a great process to get these up and running. That we have this commonality. The training will become a commonality. If you've done the training in Queensland, your ticket will, I won't say it'll allow you to work in Victoria. There probably will be some gap training required, but it's not where you've got to do the entire Victorian course versus the entire Queensland course. So that's the end game we're looking towards. But yeah, so these are good documents as reference documents, including the Australian Standard 1742 Part 3. It's important that as auditors, you don't need to know it from cover to cover, but to know where you can reference information, and these are the documents, these guides, and also the Australian Standard 1742 Part 3. And copies of these are available on your packs that I'm sure Ken has sent out or will send out or made available. Is that correct, Ken?
Yeah, they're housed in the Moodle resource folder there, so everybody should be able to jump in and get those. And of course, any Austroads documentation, guides and everything these days are free, and all you need to do is create your Austroads login and you can download them all anyway.
There we go. Thank you, Ken. Excuse me. So, and these are the issues that we come across that cause, or can cause, I should say, the travelling public to lose, I suppose, faith in the way that we manage our roadwork signing, or we manage our roadworks. You've got the 40 on one side, the 100 on the other side. We've got a traffic controller, we've got prepare to stop. So, there's a potential that we will need to slow down. There'll be workers there, and there's a potential we might have to stop because of the traffic control that's been put in place. But, having that 100 on the other side, what's the confusion for the travelling public? They now have to make a decision. Do I travel at 40? Do I travel at 100? Do I split the difference? This is the confusing part for the travelling public, but it is putting the workers and also the travelling public in danger of the potential hazard that is up ahead. And I pulled up at this site. It was a power company work site working on the Vic Roads network, or the Department of Transport network. And I spoke to the supervisor on site, and I said, "Do you realise you're traffic management is incorrect. You've got an incorrect a sign that should be covered over. And he said, oh, don't talk to me, talk to the traffic management guy. And that was probably disappointing to hear that for a start, because ownership of the site doesn't belong to the traffic management company. And that's a point of this slide. There's a couple of points in this slide, but that's one of them, that you cannot pass on that responsibility, excuse me, of the management of the site, the ownership of the site. It sits with the person who is undertaking the work. In this case, oh, excuse me, I'll have to have a drink, sorry. In this case, it was the power company, and you can't handball that responsibility onto the traffic management company. So, and I then spoke to the traffic management company, and they said, oh, we just didn't have enough signs. You know, we thought if we put the 40 next to the 100, people would obey the 40. These are the issues that, you know, the planning to make sure that it's all done correctly. So again, if you're out auditing the site, that you talk to those responsible. The responsibility doesn't just sit with the traffic management company. The responsibility sits with the owner of the site. You know, it might be the Department of Transport. It might be the council. It might be the contractor that's been engaged by Department of Transport or the council. But you know, ensure that you're talking to those people about the site, because they're the ones who are ultimately responsible to ensure the site is in a safe condition for people to travel through the site. So why road safety audit a construction site? Roadwork sites typically involve a change of speed environment, additional conflicts, confined space, which can increase the potential for crashes. So yeah, the people who, you know, we're creatures of habit. We drive from A to B, going to work, going to the supermarket, whatever it might be, taking the children to school. That yes, we're the creatures of habit. But then we come across roadworks. All of a sudden, that task of getting from A to B has been changed on us. So therefore, unless the signing is, you know, all the signs and devices are correctly put up, correctly managed, and give guidance to the person that has approached that roadwork signing, unless it gives good guidance and good pre-warning, we can become really oblivious to what we need to do to follow to make sure we get through the site safely and ensure that the workers are kept safe. So it's so important that you know, advance warning signing is well placed, gives enough warning. It's not too far away where we forget of, you know, we see a roadwork ahead sign, then we don't see roadworks for, you know, a couple of kilometres. All of a sudden we're oblivious to it, and, you know, rightly so, because, you know, we really should be, if there's a roadwork ahead sign, we should be seeing roadworks. You know, there are cases, and I remember when they were doing the Westgate Bridge, there was works being undertaken underneath or the side of the bridge, and you couldn't really see the workers, but if there was an errant vehicle, there was a potential that they could hit those workers. And so they signed that accordingly. They actually put up a standalone sign saying something like, you may not be able to see us, but we are there, please slow down. So, you know, you can make or, you know, have signing that is suitable for, you know, special circumstances. And of course there's rules and regulations about, you know, font sizes and the like, but you know, we've got to be able to ensure we get the traffic slowed down to a pace that is going to, if, you know, there is an errant vehicle or for whatever reason, that yeah, the workers are kept as safe as possible. Traffic arrangements during road work can change several times, and, you know, they don't resemble what the permanent arrangements were or will be. And audits at design stages can give a little indication of the safety of the temporary work. So, we do look at the different stages of undertaking, road safety audits. We can look at the design, the traffic management plan or the traffic guidance schemes. Question, Ken, can we ask the group, is anybody can tell us the difference between what a TGS and a TMP, traffic management plan, or a traffic guidance scheme? Is there anybody in the rooms that might be able to?
Yeah, let's see. And we'll give out a prize or two for this one as well. So we've got, what's the difference between a traffic management plan and a traffic guidance scheme? Okay, answers are coming in. So we've got TMP is a report, TGS is a plan drawing, TGS is part of the TMP, traffic guidance scheme and traffic management. Oh, that just sort of ends there. Okay. TGS shows set out of signs and lines. TMP includes options assessment, risk assessment, management process. TGS is the actual plan for implementation. Traffic guidance shows the flow of traffic when the site is set up, and TMP shows the risk. It's a report. Traffic guidance scheme is a plan showing temporary traffic management. TMP is a full set of full report that includes the traffic guidance scheme. Lots of people, I think, getting things on the money there, but
absolutely. And there was one early in the piece. It was there was, you're right, Ken, there was a lot of people who were nailing that one for sure, but there was one early, I just can't quite remember.
I think it was the TGS shows the signs and lines, etc. TMP includes options assessment, risk assessment, management process.
Yeah, I reckon there was one before that. There was one before that was even a bit more, not quite as, but that one's correct, absolutely.
TGS is part of the TMP.
Well, yeah, no, perhaps, yeah, no, that's semi. The one where they talk about risk assessments and the like, and that is correct. The TMP, traffic management plan, is that whole suite of information that is required to ensure the site is managed in a safe way. So it'll even have, it should include, emergency contact numbers. It should include, if there's schools or bus routes or bus stops or anything that could influence the road network that needs to be managed. So it'll have the risk assessment, as the person said. It'll include, yes, the suite of traffic guidance schemes that are required to ensure that whole job is managed from start to finish. It might have one TGS, it could have 20 TGSs for the different stages, for night, outside of working hours, while the workers are on site. So there's a whole suite of information that's required in a traffic management plan to ensure the whole site is managed and the works are managed, which does include these traffic guidance schemes, which is basically where the signs go and where they're located.
Good, and Kez will give out a few prizes there.
Thanks, Kez.
Okay.
We'll go back to my screen here. There we go. And the construction, that we were talking about, why road safety audit a construction site. Often our construction contractors may not appreciate the finer points of traffic management, roadside safety, and the operation of safety devices. And the contractor wants to get a job done. They want to, whether it's a reconstruction, whether it's bridge works or pavement works, or like not be just maintenance type works. They're wanting to get the job done. They're wanting to make sure that their quality of the job is based upon their pricing and whatever. We won't go into those details of that type of work, but Yeah, sometimes I'll say, well, if as long as we slow the traffic down to 40k an hour, I've got a traffic controller in place, happy days. But that's not where it should be. What does our risk assessment say? Will the traffic be further than 3 meters away from our workers? Do we really need to slow it down to 40? Is there options where we're not having to stop traffic and have these shuttle operations? Can we not use traffic controls? Can we have portable traffic signals? Can we have boom barriers that have a stop sign on them, rather than having a person physically with a stop slow bat that has to step out or be close to the traffic? It is often, as I just said, that they think 40k an hour traffic controller, that's where our works, how we will manage our works. But can we actually create a two-way so we're not actually stopping the traffic? We've got to look at all these other options that are available to us to make sure that traffic get through safely and the workers are safe. You're going to hear me say that probably too many times, but if I can get that message through, that's our ultimate end game, is to ensure that safety of everyone that comes across roadworks, that we get through, past, around that roadwork safely. Then that's what we are wanting to achieve. To check that standard arrangements are applied for consistency. And again, this was one of the reasons for these Austroads guides was, let's have that consistency not only across one state, but across all our states and territories. And while New Zealand are probably more, their signing is probably based more around the UK type signs, we're still trying to get that consistency for Austroads. So the arrangements, we should be that advance warning, slowing them down, or making sure that the speed is appropriate for the site conditions and the guidance, getting the traffic through safely, and then once the traffic has got through the site safely, letting them know that that's finished and they can continue on following the normal road signing that is applicable to that road. Again, I'll repeat that we give that advance warning. We manage the speed of the traffic to ensure that the workers are for the safety of the workers and the travelling public. We guide the traffic through that site, whether that's through cones, bollards, temporary crash barriers, whatever it may be, delineation, using all different signing that is available to us. But once the people traffic is through that work site, we let them know that that's finished. So it's putting it in those terms that we even as road safety orders, we have that in the back of our mind to ensure that all those steps are being managed to ensure that the site is being managed safely. To assess whether standard arrangements are adequate for the particular conditions. Again, have we ripped up the road? Is there loose material? Victoria had a campaign, it's going back a couple of years now, when the tools go down, the signs go down, or the speeds go down. And this was around practice management, that if we do rip up a section of road, that we, at the end of the working shift, when workers are going to be leaving site, we don't leave the site in a manner that requires the site to be left at, say, 40 kilometres an hour. We actually have that loose material compacted. We have the water truck out, so the dust is being suppressed, and so that the speeds can be managed differently for working hours outside of working hours. But unfortunately, far too often I come across sites that, especially at night time, outside of working hours, are still signed down to 40 kilometres an hour, yet the pavement conditions are adequate for vehicles to do probably 80 kilometres an hour. The minister was pushing on it, and I missed that comment, Ken.
I think it's just
Sorry,
come in. Oh,
I saw a message pop up about the minister.
the minister says the minister was pushing. So when Ash was at DOT, the minister was pushing on it, and then they had to take it back as the site may not always be ready to go back to the normal speed.
Yeah, and I'm glad we've got a little bit of discussion in that space, Ken, because as I said, that when we rip up a piece of road, we have changed those driving conditions. Yes, there could be loose material, yes, but we don't need to be down to 40 kilometres an hour. The only reason 40k an hour was introduced into our signing Australian standards, it was before the guidance material, was for worker safety. That was the only reason it was introduced. It wasn't for poor management of sites. It wasn't for the the inadequacies of the way the site was managed. It was for worker protection. South Australia have had it for as long as I've been probably alive. That 25k an hour. You see a road worker in South Australia, or a roadwork truck, a vehicle, you have to slow down to 25. I think there's a few different rules around it these days, but that's essentially what it was. It was to protect the worker. But in the case of when we rip up a road, we don't need to slow traffic down to 40k an hour. It'd have to be so rough, and so the material would have to be boulder-like to make traffic stay at 40k an hour. And that's what this campaign was about, that we remove the 40k an hour, the workers no longer on site, let's put it back up to 60 or 80, which is applicable to the driving conditions. Putting it up to 100, probably dangerous, but we have the risk assessment process to give us that information, and leaving it 40k is bad practice, especially when there's no workers on site. Unless, and I'll put the caveat on it, that unless the site conditions demands that. It might be the lanes are so narrow. It might be the bridge works that there could be a conflict because of the temporary bridge that's been put in place. So there's always rules to the exception, but that's what we should be looking for. To avoid conflicting messages from permanent and temporary devices and between lines, signs, delineation, other devices. Again, it's a bit easy just to put up a few signs, but do they actually conflict with the permanent signing? And again, as road safety auditors, this is the picture we need to look at to ensure there's no conflicting messages. And to check that signs are used for their correct purpose. Unfortunately, I see far too often the prepare to stop being used with roadwork ahead. The prepare to stop must be used with either portable traffic signal signing or the traffic controller sign. That's the reason for the prepare to stop, and it should be used in conjunction with, as I said, the traffic controller symbolic sign or the portable traffic signal or the signal signing. Provide safety for works personnel as well as the travelling public. And I've harped on this the entire presentation, and I will continue to do that, because this is what we need to achieve to ensure that everybody gets through this site, that it's managed well, there's no guesswork, that the travelling public, the guidance for them is spot on, and the workers, they're contained, they know their area of working, they know the areas where the travelling public will be going through, and it's an exclusion zone. It's a bit like with reversing vehicles. We need to exclude reversing vehicles from people on foot, and we need to exclude workers from the travel path. So it's so important that we understand and manage those situations. And the connection of crossing points for works traffic and public traffic is safe. You know, often we will have construction vehicles coming in and out onto the road network. The other one we should be also ensuring is that the local businesses aren't affected by our signing as well. You know, and that's part of the planning. That's part of your traffic management plan, to look at what effect this will have on local business. Are we actually inhibiting customers from getting to their point of to their stores and the like? So it's really important that, again, that's managed accordingly, and we're not you know, disrupting people's business. This is on my walk last night. This is in Warrnambool, and the road on the left, it's a, well, I suppose, I don't think it's a private driveway, but it is gives access to 2 or 3 houses. But there's a development going on, and as you can see, it's the road itself is through a cutting, but we have that sign: road closed, pedestrian, and the road closed. There's nothing beyond that. There may have been access to an old gym or something, but you know, it's been closed for years. But the pedestrians use other footpath. Where is the other footpath? It's a drop. Now, it's probably okay for able persons, but again, Ken, I'll just quickly ask, what group of our public would be affected by this, that may become unable to follow what's been put up?
Yeah, okay. Let's see if anybody's got ideas. Okay, well, we're getting all sorts in. Age, children, elderly, disabled, mobility impaired, elderly, disabled, pram and elderly.
Did we get the visually impaired? There we go. Well, I see the blind there. So visually impaired, absolutely. You know, we've got to be so mindful about our pedestrians, and I'm so glad that people mention prams, children, those types of activities that people are or those types of implements that people are using. If we're not providing a safe crossing point, then we must provide one. You know, it's just, it wouldn't be a huge amount of foot traffic that would go through there, but beyond that is a river. It's a there's a landing there now that people, yeah, it's a great spot for people to visit, you know, to check out the river. So yeah, to force people when they get so close, oops, sorry, what have I done? Yeah, to force people back or with nowhere to go, yeah, we just need to make sure. It's so easy just to chuck up a sign, but its effectiveness is going to be cause so much inconvenience. You know, again, this was just a repair to a footpath in Geelong. Yeah, so again, we could have just, or the managers of that could have backfilled that, put down a hard area while they're overnight. It could have allowed the, you know, people with the mobility issues easy access across there during the day or while the work's going on. You could provide traffic control to help them across the road, and you know, it's probably another half hour on your day to fill that up, compact it, and when the concrete's arriving, take that out and provide a safe crossing point. You know, it's just a bit of pre-planning to ensure that we're not causing any grief to people who are going to be using that footpath. Because if you're on a scooter or you know, some sort of mobility aid, getting around that would have been very difficult. Non-compliant signs, you know, black on yellow, that's our normal roadwork signing. So I gather that's what the company was thinking. Let's have create that. But that's a regulatory sign. That should be red writing on a white background. yeah, so again, as auditors, we need to ensure that the signing itself, any regulatory signing, is correct. Very quickly, we're getting close to my time being up, but apart from shape, can anybody tell me what the difference between those two stop signs are? I know the colours are a little bit bit off, but yeah, is there any?
So Cheston's yeah, first in there on pointing out around one's for a normal stop sign, one's for traffic controller. One is mounted, the other is by traffic controller. So most people are on that. You want some more specifics around that?
Yeah, I think, yeah, we see the round one, yes, it's used by traffic controllers. It's also used at school crossings. But there is a significant difference between the two, and it's to do with the law.
What they actually mean.
Yes.
Well, okay. So when a stop sign is not just a stop sign, or it is a stop sign, but what do we mean by that? Any guesses on that? That's a nice little
halt.
That's a nice little trivia question. What do the road rules say around these two signs?
In the interest of time, Ken, I'll continue on. We're not getting, one needs to be accompanied by
line marking.
No, not necessarily. In the absence of the line marking, the 8-sided one, in the absence of line marking, you got to stop before you actually approach onto the intersecting road. So
you better put everybody out of their misery here, Tony. What's the
let's move. The round one. Well, let's go to the 8-sided one. As a traveling public, if I approach that, I've got to stop. But I then make a decision. If it's clear for me to proceed safely, I can then proceed beyond that stop sign. The one on the right, the round one, if it's faced in my direction, I've got to remain stopped until either the traffic controller tells me to proceed on, or the stop sign is no longer displayed in my direction. So while that round one is facing the driver must remain stopped. And that's why we shouldn't be seeing traffic controllers with the 8-sided stop sign, because that control does no longer sit with the traffic controller. It's sitting with the sign and may be detrimental to the workers further up. And this is what we need to see with our traffic controllers. Well, with their fluorescent clothing, the stop sign in good condition, so it can be seen, the traffic controller can be seen, and yeah, the direction from the traffic controller make it safe for the workers. Oops. So when to audit, and we'll get through these reasonably quickly now, because I've probably talked for a bit long, Ken. But we review the plans of the guidance scheme. We make sure we inspect the site day and night. It's so important that, with the initial road safety audit, with the early at the beginning of the construction site, any major changes to the scheme, that we do a review, but we also do a night inspection, both a day and night inspection, to understand what the conditions are in both those situations. It's so important. I'm sure, Ken, with the other audits, Jamie and anybody else has spoken, that that day and night requirements is so important. Common issues, the adequacy of the warning signs, the proposed speed limits, and I've probably covered a lot of these off with my earlier spiel on when and why. But the conflicts between the permanent temporary features, the likelihood of mud and dust obscuring the devices, have they been cleaned properly? And this is the day and night will tell that. A sign during the day may look okay, At night time, it may not even show up in the headlights because of the mud or dust. The appropriateness of the traffic barriers, have they been installed as per the manufacturer's specification? And that's so important to ask that question. Have the provisions for the pedestrians, less agile ones, providing adequacy for the cyclists, have conflict points been managed? And finishing up, and Ken, you're still going to give a bit more detail in this space?
Yeah, I'm going to show them the new prompt lists.
Yeah. So look, I'll just I might let you provide detail in that space, Ken. But if there's any final questions for anybody, I'm really happy to take these over the next couple of minutes. But I just will reinforce that the importance of a road safety audit. People, as road safety auditors, the role you play in ensuring that our roadwork sites are safe. We're looking after the travelling public. We're looking after the workers. You know, and at the end of the day, we should go home in the same condition we go to work in. We might be 8 hours, 9 hours older, but that should be it. We shouldn't be harmed by our working conditions. And as road safety auditors, we actually have an important role in that, in managing roadworks. I think I'll leave it there, Ken.
Thanks, Tony. Yeah, it doesn't appear that anybody's got any immediate questions here, but of course, you can get in contact with Tony through contact details on the slide. Of course, come just through Safe System Solutions, and we'll ensure that we put you in contact with him if you want to discuss any of it in further detail. But thank you, Tony, and we'll jump into a few other things here, so leave you to it.
You've got the screen back?
I've got the screen, I think. I do.
Excellent.
Okay. All right. Well,
thanks, Ken.
You.
Thanks, everyone.
Thanks, Tony. Right. So the last couple of little things I want to cover here are associated with the prompt list, which Tony's mentioned, and I've mentioned a few times, and I talked to you a little bit about them for the some of the other modules. These are in the back of the Austroads Guide to Road Safety Part 6, which is the road safety audit one. And what they start with is a thing called, well, we called it front loading. Now, these front loading questions are all just about the context of the project you're looking at as an auditor, giving you a bit of an idea of why is the project there, you know, what are the different things in the environment here and the like. Okay. Like anything associated with these prompt lists, then this is for your thinking and your notes only. You don't hand this in with the audit report. And then after those front-loading questions, there are all of these specific questions: local alignment, general aspects, intersections, walking and cycling, traffic signs, lines, marking, lighting. And they each column represents a stage of audit, as we've been talking about. And you can just look in at those and you'll get lots and lots of questions. There's pages and pages and pages of them, and they prompt your thinking. They're not covering everything. You've got to logically look at the scheme and think generally about other stuff, but this may spark you to think of an idea or investigate something that you may not have before. So you will get some practice using those. In the final assignment, we'll encourage you to have a look at that. But they're thought starters only. Stand back, look broadly at the project. There's a lot of stuff in there that you're just going to go, well, it's not applicable. Like there is no pedestrian crossing in this, or there is no roundabout. So why are we asking questions about roundabouts? Well, it's trying to cover every road scenario there is out there in these prompt lists. So you're just going to have not applicable or unknown for a lot of them, and you don't submit that. Okay, so what I want to do in the last 5 minutes here or so is talk you through this idea of getting a treatment or recommending a treatment and then categorizing it into primary or supporting. The reason I'm focusing on this again, I did this in module 1, I'm going to do it in more detail now, is because this is one of the things that people find it hardest to get their head around. And they lose marks in the final assignment associated with incorrect categorization of primary or supporting. So I'm going to use an example here to show you, but I point you again at this document, the Safe System Assessment Framework, which has lists of treatments and categorizes them into primary and supporting. Primary treatments are our ones that virtually eliminate the potential for fatal or serious injury occurring associated with a foreseeable crash type. Supporting are things that we don't think will virtually eliminate the potential, but do reduce the risk. So let me go, I'll go through one example, and then if you've got confusions, I'll do another example, and I'll do another one, and I'm happy to keep going on this until you start to get your head around it. Okay, here we go. I'm going to use Jamie's example there of car parking. Okay, so if we've got a vehicle coming up here, and say we've got operating speed maybe 65 kilometers an hour or something like that. Okay, and we've got a vehicle, you know, here, and they can't see this other vehicle. Okay, that is, so that we will write up as our issue. You know, the parking spot creates a sightline impediment, the vehicle's exiting. This could result in a vehicle exiting the road being struck by a vehicle coming through, and you know, some risk factors that increase that, and you risk rate it, whatever it is. Then you make your recommendation or your recommendations. Now, the first recommendation you might make potentially, and a lot of you sort of said this, was, hey, well, why don't we remove that car park? Okay, remove that. And there we go. We've opened up sightlines. Maybe you did a sightline calculation and now it's in view. Okay. That is a supporting treatment. Okay. People want to call that a primary, but it is a supporting treatment. Why is it only a supporting treatment? We've identified the issue, which was, you know, blocking sightlines, and we've removed that. But exactly as Chesson has popped into the chat right there, that crash can still occur. Absolutely. Okay, it's less likely to because this driver can now see, but they might, you know, make a bad decision. They might, you know, who knows what else could happen. Maybe a truck, you know, has decided to park here and do their unloading or something. Or maybe we've got, just a driver who, has just made a bad decision, made a bad call. Maybe they're a little, whatever it is, you know, there's all these reasons why we can still have this crash occur. And it still occurs here at the same speed, which is above our tolerable 50 kilometer per hour for the right angle crash. Okay. So that is why that's only a supporting. So it's a good thing to do, to like opening up those sight lines. Great, fantastic. But that is not going to eliminate the death and serious injury. What is a primary one at this location would actually be something to reduce the energy of the potential crash to within those tolerable levels. So maybe that could be a raised platform here that reduces speed down well under 50. it could be, as I'm seeing there, it could be a roundabout, because that, again, like if we had a decent roundabout in here, you are just not going to have this right angle crash happening at speeds that can kill and seriously injure. Okay. And that's the particular crash we're interested in. So you might say, well, a roundabout, what about bikes? What about pedestrians? That's not the particular crash for this finding. Okay. Some good points that are coming in here. Okay. What about traffic signals? Is that a primary or is that a supporting? Okay. Traffic signals at this location are a supporting treatment. Okay. Traffic signals are a supporting treatment. Why? Because it's much less likely that anybody does this, but this driver can come out here and then this driver can still run the red light at speed. Okay, so we've significantly reduced the likelihood of this, but it's still there at that same speed, at that same energy. Again, signals with a raised platform, or if we were in an environment where we had an operating speed that was quite low anyway, then signals are fine. They're in the primary category. So I've got things stop line, like a stop line here. That I wouldn't do anyway. I mean, sorry, I might, if you've got the sight distance, you don't need a stop, but a stop line, that would be a supporting if it's going to improve things. Yeah, so Alex has put in a good point there. So a primary is defined as elimination of a crash type at a specific severity. And that's right. Like we can still have the crash type available. It's just that we've ensured that the energy of that crash type is within those tolerable levels of 30 or below, where pedestrians can crash, 50 or below for side impact, 70 or below for head on, and those all from module 1. So some things in the last 2 minutes here, some things that like I don't really need to know anything about them to tell you that they're supporting. Signs, anything to do with changing your signage, line marking, lighting, surface conditions, any changes associated with that, they are supporting treatment. It's important we get all those right. Absolutely. We've got to work on that. We've got to ensure we can do it. But you can create, if you've got a road out there and you've got all your lines, all your signs, all your lighting, all your surface, everything is absolutely spot on and it's operating at a speed where crashes can happen above their tolerable energies, you're fully reliant on humans not making mistakes. We've minimized mistakes, but they will still make mistakes. So we've got to, you've got to get that into play. So the question is it all then only about lowering speeds? Well, it's not. So if you take speeds at intersections usually have to get lowered, or here's a few examples of high speed primary treatments. You got a road, you got a roadside, and a continuous barrier system. That is a primary treatment. Okay, people can go fast. They leave the road, they hit the barrier, they run along the barrier. Primary treatment. It virtually eliminates death and serious injury from runoff road for passenger vehicles. Okay. Another one, if you are talking intersections and you want to do it high speed, well, we can have like acceleration lanes. Like as an acceleration lane up to the point where our differential speed, our delta V, is within tolerable limits. And you can appropriately do it, and often you want to do a physical. But I mean, that can be a primary treatment if done right. So it is about just energy management. Yeah, so if an intersection signalizer is operating but hang on, so you're saying operating below 50, is the treatment still secondary? Well, it's actually somewhat an irrelevant treatment option, and you wouldn't really even sort of note it. I mean, don't get me, not a relevant treatment option. It may be useful and maybe what you want to do and the like. But from that categorization perspective, you're already in primary treatment territory. Okay, so it's all sitting within that. You, in an actual audit, if you did come to that, you could write, primary, and then you might even write noting the operating speed is below that. So I hope that gets you a little bit more clarity around this, because actually today's quiz is all about this, because we're having so much, people are having so much trouble with it. We've sort of created a whole quiz around this. And you're going to have 9 questions around that. You've got 3 attempts at it. I suggest you have a go at it. Maybe look back at what came out of module 1, have a look at that, have a go at it, all right? And if you really are having no luck there, book in an appointment to have a little one-on-one discussion with one of our senior auditors to help guide you through that. It's something we want people to be much better at, and so that's why we've made that today's assignment. So jump in there, do your quiz, and we'll look forward to seeing you a few minutes early at the next session. Hopefully you've got a bit more clarity around primary and supporting, but I suppose the quiz results will tell us. Kez, anything I've missed?
No, not that I can see. That's great.
Awesome. Well, thanks everybody. And I don't think any more questions have come up. Thanks again to Tony and to Jamie for their presentations. And keep in contact if you've got any further questions.
Great.
Thanks.